Hello again, our most valued student. My name is Confident. Welcome to the revision of the Mathematics N2 question paper, and it was written in November 2020. So in this section, I'm continuing with question 3, where I show you the strategies or some ideas that you can use as you prepare for your final exams. Now let us continue to look at question number 3. And we have already done question 1 and question 2, and I'll encourage you to go through those as you will get some good methods that you can also apply. In question 3, which is 3.1, and we have got 3.1.1, it is a question that deals with logarithms, and this particular question was out of 2 marks. And the question says, simplify the following expressions using logarithm laws. And then it says, do not use a calculator. So the first thing that we are told is we must use the laws of logarithms, as well as we must not use a calculator. Now, in your Mathematics N2, unfortunately, even in your formula sheet, you are not given these laws of logarithms. It is only in N3 where they include the laws of logs, but in this particular case you need to master them and you need to know them by head. Now let us try to use that and apply a few laws. And N2 usually is it lays the foundation for the laws of logarithms which are applied in N3. Now I'm going to work this particular problem in parts. Now the first part is, I want us to look at this part which says log q of q. Now there is a law, if I can divide my page, there is a law which says if you are given, or before I apply the law, let me use just numbers. For example, if I'm given log base 10 of 10, we will use a calculator to see what we get. And if I'm given, for example, log base 5 of 5, and I'll choose another number. If I'm given log base, let's say 150 of 150, as you can see, I'm repeating numbers. So now if I can apply my calculator in this instance, the first one is log base 10 of 10. You can see that I'm getting a 1. I play backwards, and then log base 5 of 5. You can see still I'm getting a 1. Now the last one is log 150 of 150. You can see that I'm getting a 1. So in all instances I'm getting a 1. And what is the hint there? When the base is the same as the number, I get a 1. Therefore, we can conclude in this law and say, therefore, in this case, therefore, if I'm given log base a of a, I must also get a 1. So you can see that I can actually use these scenarios that I was writing to say, if the number and the base are the same, I get an A. So in the same scenario, if we're given here log base q of q, you can see that this is equal to 1 minus. So you understand how you can just use the laws of logarithms for that. Now secondly, the next part that we're going to apply is, I'm going to use again my calculator just to check a few using the second one. For example, if I have in this instance log, for example, base 10 of 1, log base 5 of 1, and log base 17 of 1. Now if I can use my calculator to check that, and I've got log base 10 of 1 equal to, I get a 0, and then the next number is a 5. Log base 5 of 1 again is 0, and then the last one is log base 17 of 1 is 0. So you can see that in all instances I am getting a 0. So again we can conclude and say, therefore log in base A of 1 is equal to 0. As long as the number there is 1, whatever base you change, but as long as you are given the number as 1, it will equal 0. So which means the next part, log base x of 1 is also equal to 0. Therefore our final answer, 1 minus 0, is equal to 0. So here we did not need to use a calculator, but we had to apply the laws, and that is how you get your answer. Let us move on to the next question. It is 3.1.2, still the same question, which says we must simplify the expression using logarithm laws, and then says do not use a calculator. And in this instance, this question 3.1.2, it is out of 3 marks. Now if I can use increase my screen and say, it says here log base 4 of 8, or log 8 in base 4 plus log 32 in base 2. You need to simplify that, and remember, you are not supposed to use a calculator. Now let us start with the first one. We are given log base 4 of 8. Now it is always good for you to know what is log base 4 of 8 and work towards that answer. The question says do not use a calculator, but it is when you must actually use the calculator where possible, so that you can see at least where your final answer and work towards that final answer. So log base 4 of 8, you can see that it is giving me 3 over 2. So I will write my answer here and say this is actually equal to 3 over 2. Then the next thing is, how did they get 3 over 2? So you'll be having here log base 4 of 8 in this case, and after that you have now to try to simplify this particular expression and ask yourself to say, how can I write 4 in this case? This is 8 in terms of 4. Now you remember that 8 is same as saying log base 4 and 4 times 2 in that case. So to get 8, we must write it as 4 times 2 or 2 times 4, whatever the case. So now you can see that this is one simpler way you can write 8. So 4 times 2 is equal to 8. And then there is a law in logarithms which says when there is a multiplication sign, it says log in base A of x, and then it says plus log in base A of y is equal to. So when there is logs with the same base and there is a plus sign between the logs, what you need to do, you have to write the log with the base, and then you say x times y. So this is an important law. Now if I read this law in this direction, I will read it as log in base A of x times y is equal to. So it means when I've got a base A and x is multiplying y, I can write it as, separate it as log A of x plus log y in base A. So you can see now that when there is a multiplication sign, it is the same as adding the two logs. So the multiplication is replaced by adding. So this is the first law of logarithms. Now if I can use this particular law in here. This is where I'm going to apply it to say now log base 4 of 4 times 2. Now remember, dot and times, it means the same thing. It will be equal to log base 4 of 4 plus log base 4 of 2. So that is one way that this can be done in that case. So we can therefore simplify it in that fashion. Now the next one that we need to, if I can write it down, the first part, and say log base 4 of 8 is equal to log base 4 of 4 plus log base 4 of 2. So this is the first part. Now the next one that we need to simplify, similarly, if I can just erase that part. Remember now, this log base 4 of 8 gave us 3 over 2, which we are going to try to prove too. Now, if you can also quickly take a calculator though, just to check if you are still within doing the same you're in the same method, you can take a calculator and say just log 4 of 4 plus log 4 of 2 there, and see where it takes you. It still gives you 3 over 2, which means you are still in the right direction. Now let us look at the next one. Now the next one is log base 2 of 32 is equal to, again, you can use a calculator for that one, and you check what it gives you. That's log 2 of 32. It gives us a 5. So you can see that this is equal to 5 when we use a calculator, remember, and the question says we mustn't use a calculator. So now we have to prove how the calculator got the 5. So now if I can write it and say log base 2 of 32, now you need to be good here because 32 can be written in different ways. In terms of exponents, if you remember your exponential laws, if you say 2 to the exponent 3, you can see it gives me an 8, and then you can say 2 to the exponent 4, it gives me 16, and then you continue and say 2 to the exponent 5, it gives me 32. So you can see that this becomes log base 2, and then you have got 2 to the exponent 5. So now when you have done that, there is a law in the laws of logarithms which we are going to apply in this case, which says when you are given log in base a of m to the power of n. Now notice the base is a, and then you have got m to the exponent n. What happens is the n here is going to drop down so that you have got n, then you have got log a to the power of m. So you see how the n dropped down to that, meaning if I have similarly log base 2 of 2 to the power of 5, this will be equal to, the 5 is going to drop, then I've got log, and then I've got 2 of 2. So you see that. So I can actually now conclude and say, in this case, log 2 of 32 is equal to 5 log 2 of 2. Now the next part of the law Remember, this is your working that you must not lose, so you need to be showing your working. Now the next part of the law which you need, if I can just keep my page and erase this part, the next part of the law which you need to recall, we just looked at it previously, is the law then that says if you are given log a of a, we just looked at previously, if the base and the number are the same, remember it gives us a 1, and we are noticing that part in these two areas. So which means we can say in this case this is equal to, now where is log 8 of 4, remember log 4 is 1 plus log 4 of 2 plus 5, and then log 2 of 2 also is a 1. I think you remember it's actually gave us log 2 of 32 gives us a 5, which you can see that is 5 times 1. And then we can continue here to say 1 plus 5 plus log in base 4 of 2. Now 1 plus 5 is equal to 6 plus log in base 4, in this case is log base 4 of 2. Now how do we simplify this last part? As you can see now, it says we need to simplify log base 4 of 2. Now there is a law which allows you to change bases. Now suppose we want to change this particular base into base 2. For example, if I am given, remember they say to use the laws of logarithms, if I'm given log base a of b and I want to change everything into this particular base, I will say this is equal to log in base b. Now the b that is on top remains on top over log, I repeat again, the same base b, the a that was the base is the one that is under. So this is how I change a base. So if I can use the same principle here and I want to change everything into base 2, so I will have the log base 2 on top, and then the 2 will be on top over log base 2, and the 4 will be below, as you can see that. So now I can conclude and say this then becomes 6 plus log base 2 of 2 over log base 2 of 4. I think you can see where it's going. Now when I've done that, it becomes 6 plus, again, log base 2 of 2, the 2 and the 2 are repeating, becomes 1 over, and then again we've got log base 2 of 4, and I'll remind you to say, remember 4 is same as 2 squared. If I can take a calculator there, 4 is same as 2 to the power of 2 is 4. So this will be 1 over log base 2 and 2 squared. And then if we follow the same way we did by having an exponent that drops down, we say this is 6 plus 1 over, now the exponent here is going to drop, so that I've got 2 log base 2 of 2. This continues to say 6 plus, now as you can see now, what I have is 1 over 2 there, as you can see that. So I've got 1 over 2, log 2 of 2. Now for me to be able then to simplify that, I will have to say 1 over 2 of 1 like that. Then the answer there will become, if I can say 6 plus half, in this case 6 plus 1 over 2, you can see that it is giving me 13 over 2 as the final answer. So now this is what it simplifies to. But remember, you can check your answer, and once you take a calculator, and in the original one you punch and say what is log 4 of 8 plus log 2 of 32. Then when you have done that, you say equal to, you can see that the answer is 13/2, which is similar to the answer that we got here. So you can see that even with the calculator, it agrees that the answer is 13/2. So that is how you can use the laws. I know I was winding along this, but it is one of the ways that in your mathematics N2 you can actually use to solve this. A person who has already studied these laws and is doing mathematics N3 could have actually done this much quicker by identifying that in this particular stage here, in log base 4 of 8, they needed to change that base. But since you are still learning the usage of these laws and practicing them, it is always advisable to take even the winding routes, because it is a way of practice. Let us look on to question 3.2, and in question 3.2 it says simplify the following here without using a calculator, and then says we need to show all the workings. And this particular question is 2 marks, which is not a lot, so the answer might not be as difficult. And then says 3.2.1, that is what you are given there. So now if these now are exponents, and again you need to know your laws of exponents. Now in your mathematics N2, the logarithms and exponents, they go hand in hand. So now you are given this particular question, and in this particular question here we have got 1/8 to the exponent minus 2/3. So there is a negative. So if I can have a place like here to show my working. So if, for example, there is a law in the laws of logarithms which says if I'm given a to the power negative m, now to remove this particular negative I must say 1 over, and then when I write my a, now the m will be positive. So that is how you can remove this particular m. And then similarly, this law can be written in this direction, which says if I'm given 1 over a to the power m is equal to, if I want to remove this particular division line, I must say a. You can see that there is no division line, but now to remove that I must introduce a negative sign, and the exponent now becomes negative. It therefore means if I'm given a number such as 1/2, so now remember the exponent under 2 there, it means the default is 1. If I want to remove the division line, it will be same as saying 2 to the exponent negative, which is -1. So if you can test that with a calculator and say what is 2 to the exponent -1, you can see that it is 1/2. So any fraction, if you are given 1/5, you must know that this is also the same as 5 to the power -1. Similarly, if we are given 1/8, this is same as 8 to the power -1. So in our question here, we can conclude and say this is equal to 8 to the power -1. But remember, in this case, it is in the exponent -2/3. It's an exponent. Now, when you have done that, it is also maybe before we do that one, so that I don't confuse you with the laws, there is something also you can remember. What you can remember is even our 8, if I want to use the law here, you remember that 8 is actually 2 to the power of 3. If I say 2 to the exponent 3, remember it is 8. So which means I can use further take this law down exactly as it is to say 1 over 8 is equal to 1 over 2 to the power of 3. Remember, 8 is 2 to the power of 3. Now, to remove this particular fraction, it will be 2 to the exponent. Now, to remove the fraction, I put a negative. Just like in this particular scenario, I will also have 2 to the power negative 3. So that is actually much preferred than this one, because I still need to change my 8 there. So then I can write my 8 in this case as this is equal to 1 over 2 to the exponent of 3, and then after that I have got minus 2 over 3, which is equal to 2 to the power negative 3, and then I have my negative 2 over 3. And then when I've done that, the two exponents here that you are seeing, these two exponents here, when they are like that, it is similarly, there is a law of exponents, and that law of exponents says if you are given a to the power m and then there is an n outside, these two exponents actually it means a to the power m times n. They are multiplying each other. So even here you are going to have these two exponents multiplying each other, which is 2 to the power negative 3 times negative 2 over 3. You can use a calculator or you can simplify without one if you're able. So it's negative 3 times negative 2 over 3, and then you can see that is giving me a positive 2. So this is equal to, in actual fact, the 3 cancels the 3, the negative cancels the negative, you can see the 2 that is remaining. So it is 2 to the exponent 2. Then you can simplify and say what is 2 to the power of 2? 2 to the power of 2 is equal to 4. Now what I just did, which I don't usually recommend, is I managed to work this problem out without knowing my final answer. But as I said, when the question says do not use a calculator, the first thing you can see says simplify the following without using a calculator. The first thing I was supposed to take was my calculator and see what was the final answer into this question so that I can work towards that answer. So in here I had that 1 over 8, and then to the exponent again negative fraction, which is 2 over 3. So that's the first step to do, so that at least you know what you're working towards. You can see that the answer is 4, and in this case already we've managed to get already our 4. So this was the first step that we were supposed to do. You do this in a rough you write your answer in a rough in your rough work, which is, it can be in the back of your answer script where you're going to scratch it out, or it can be in your question paper where you quickly write it down just to know where you are going towards. And then after that, if you make an error, you are able to check out where did you make that particular error. So that is how you could have approached that one. Let us move on to the next one. It says we're also supposed to simplify this. We're still looking at 3.2.2. It says simplify without using a calculator and show all working. And this particular question is out of 2 marks. And here they were just testing you if you know your laws of exponents. If I can expand that, so you can see that is what we are having. And one of the simpler things to do is to understand is to collect all your m together and collect all your n together, and then apply the laws of exponents. Now, but before we do that, you need to understand a few things. For example, what does this sign mean? It's, as you can see, there is a 3 there, and then there are numbers inside there. So this particular sign, if you see the 3 there, it means it's a cube root. Now you can write this as something like that. To remove that cube root, you have a power which is 1 over 3. That is basically what that particular cube root means. So these two, if you want to remove the 3, it is even saying 1 over 3 as an exponent. Meaning, when we are writing here, I'm going to collect first the like things on the numerator or the top, which is m to the power 5 dot m to the power negative 2 dot means I'm multiplying dot n to the power 7 dot n to the power negative 4. You can see I'm just rearranging all over, and then that particular cube root, as I said, you put a bracket, but we still have inside m squared dot n squared, and it is multiplied by 9 over 2. Don't forget, we said there is a power, that cube root, it is power 1 over 3. So the 1 over 3 will come and multiply that. It can be 1 over 3 times 9 over 2 or 9 over 2 times 1 over 3. It works out the same at the end. Then this can now cancel. 9 over 2 times 1 over 3. You can actually simplify it. It will give you 3 over 2 in that case. So you'll be having, it's up to you how you want to simplify, but on top you can use the law which says here at the numerator, if you are having m, for example, m, actually let me use not the m here, from the laws of exponents, it says a to the power m dot a to the power n. If you are having the same base and a multiplication sign between the bases, you are going to write that base and you add the exponents, which is m plus n. So basically that's what we're going to do there at the numerator, which is m, the bases are the same, so we're going to have 5 plus minus 2. Again, we do the same thing to the n, which is n to the power 7 plus minus 4. There are many ways you could have done this one, many different ways, but I'm just going to be working it as it unfolds. Now the next one that I'm noticing here, remember I have got now m squared n squared to the power 3 over 2. So now when I'm having that, it means if I'm having, remember a, in this case, I think I did it previously, a to the power m, and then there is an n outside, it means these two are multiplying, so you have a to the power m times n. So similarly here, I will have m to the power, okay, actually let me use this law. If you are having a, the actual one is a dot b to the power m like that, and there is an n outside, it's saying a to the power m times n dot b to the power m times n. You can see that this power affects b and this power affects a, and you distribute it across. So similarly, now if there is m squared here, now you can see that that particular squared here, if I can actually use, the squared is here, but that particular squared will be affected by the power outside, which is multiplied by 3 over 2, and then again you continue and say dot n squared, and then again you say times that particular exponent that remained was 3 over 2 after I managed to cancel the 9 and the 3. Then with that you can cancel that and you can cancel that. You can see that this simplifies to, in this particular case, now 5 minus 2, it is m to the power 3 dot, now 7 minus 4, it is n to the power 3 all over, again in the bottom I've got m to the power 3 dot n to the power of 3. Actually, it came out more simplified in the sense that I can now cancel the top and the bottom, the top and the bottom, and the answer simply gives me a 1 in that case. So this is how it went. I quickly solved it. But someone can also argue and say, couldn't you use the laws of exponents? You can, if you want, to say here m cubed dot n cubed. Now I can take it to the top and say dot. Remember, when m goes to the top, it will be negative 3 dot again n to the power negative 3, and then I continue to say m to the power 3 minus 3, or 3 plus minus 3, and then n again is 3 plus minus 3. So now this will be m to the power 0 dot n to the power 0. But if you remember, any number to the power of 0 is 1 dot 1, which is equal to 1. It was not necessary, but for argument's sake you could have done that one. Now that is how you could have solved that. Let us move on to the next question. Now this was question 3.2.2 if I'm not mistaken. Now we are moving on to question 3.3, and 3.3 also had different questions under. Now 3.3 says solve for y in the following equations. We are solving for y here, and we're given that, and this is out of 4 marks, which is quite a lot in terms of you ensuring that you don't make errors there, so that you can get all your marks. So we are supposed to solve that. We are still looking at logs, but now these are log equations or logarithm equations, and you are given log base y of 2 is equal to log base 2 of y. Now what are you noticing there? You are noticing that the number which is 2 is a number on one side, it is a base on the other side. Y is a number on one side, it is a base on the other side. So the only way to simplify that is to make sure that you match the bases. So you either have to convert the other one into base y, or you have to convert the other one into base 2. Whatever way, your answer will be the same. So for argument's sake, suppose we want to convert, or we want to make everything into base y. In other words, this one already is in base y, so we need to convert that into base y. So now, as I told you previously, if you are given, this is the law of logarithms, if you are given log in base a of b, and you want to convert everything here into base b, actually into base a, it would be log, in this case, into base b, sorry, it would be log in base b of b, because everything is in base a, over log base b of a. So that is how you convert that. So if I want to convert, I can also here log with the same argument, log base 2 of y, and I want to make it into base y, I will have log base y of y over log base y, because 2 is a base, it comes under like that. So then I will have now log base y of 2 is equal to log base y of y all over log base y of 2. Now you can see that everything is under the same base, and that particular base is y. And remember, if you have a base and a number, this equates to 1. So it will continue to become just to make sure that everything is in fractions. So you'll have log base y of 2, then you say over 1 is equal to 1 over log base y of 2. You can do that. There are two ways here that you could have solved it, and one that made me say over 1, you can cross multiply if you want. Now if you cross multiply, it means the top multiplies the bottom and the top multiplies the bottom, or you could have multiplied both sides by that and both sides by that. So it's up to you, as long as you're gonna get rid of that fraction. Anyway, it was going to work. So in this case, for us, I used the method of cross multiplying, which means log base y of 2 will multiply another log base y of 2, and it will give me 1 times 1. So basically that is what is happening. So now you can see 2 of these is same as log base y of 2 squared is equal to 1. Now for me to simplify this one, since there is a squared, to get rid of the squared, I have to square root both sides, and I have to square root both sides. Now square root here, I will remain with log base y of 2 is equal to square root of 1 is a 1. Now this is the final part where you need to know how to solve it. Now that's what you wanted to achieve, so that you have got log on one side and a number on the other side. Now there is a rule that you must use, not a law as such, it's a rule which says if you're given log base a of b is equal to, for example, m here, so what you have is you will remain with b here and say b is equal to, then you take a, which is your base, it becomes the base in the exponent, and that number becomes an exponent like that. So that is how it converts. Now to convert this one in the same way, you will have to remain with the 2 here, so that you're going to say 2 is equal to, and then you will have the y being the base, 2 is equal to y, and the 1 will become the exponent. So in other ways, 2 is equal to y, because y to the power 1 is a y. So therefore our answer is y is equal to 2. Remember, the question says we need to solve for y here. The question is solve for y in the following, and you can see that our answer says y is equal to 2. Now equations are always good because you can test your answer. So you go to the original and see if you can, when you put your answer for y is equal to 2, what I'm gonna get. On the left hand side I have log, where there is y, remember I put 2 of 2, I'm getting a 1. So here on the left hand side, when y is equal to 2, I get a 1 here is equal to. Do the same thing on the right hand side, and you also test it again and see what you're getting. Now on the right hand side I have got log 2, and my y again, remember, is 2. I'm also getting a 1. So 1 is equal to 1 means left hand side is equal to right hand side. When it's like that, it means our answer for y is equal to 2. It is correct in that sense. So that is how you simplify that log equation. And then let us look at the next 3.3.2. Now if you can see, it's out of 2 marks, but after that there is 15 marks, meaning this was the end of question 3. It was out of 15 marks. Again, we're still solving for y, and if I can expand that, as we're concluding question 3, we're solving for y. Again, you are still dealing with exponential equations. So you can see how the questions were. First it was the laws of logs, the laws of exponents. Now it was log equations. Now it's exponential equations. So examiners here, we're just trying to check how good are you with your laws of exponents and everything. Now on this one, if I can also do a few things here to say, what the examiner here wanted to check was, are you able to simplify 8, 4 and 16? And these numbers 8, 4 and 16 are always interesting, because 8, remember, we did simplify. We said 8 was 2 to the power of 3, and 4 is 2 to the power of 2. Now the next one is 64. Now 64 can be written in terms of 2, and you can just do your trial and error and say 2 to the exponent 5, we say it is 32. 2 to the exponent 6, you see it's 64. So here is same as 2 to the exponent 6. So now you can write the 8y and say this is same as having 2 to the exponent 3, but remember there is a power y. It means you put a bracket and you put your y outside, over, again 4 is 2 to the exponent 2, you put a bracket outside, there is a 2y now, is equal to 64. There becomes 2 to the power of 6, and then outside you put a -1. And you remember these exponents, what it simply means is they are multiplying each other like that. So you can move on to say 3 times y, this is same as 2 to the power of 3y, over 2 to the power of, now 2 times 2 is 4y, is equal to 2 to the power of 6 times -1 is -6 in this case. Now moving on further, you remember I can take 2 to the top, and when I mean 2 to the power 4y to the top, and when I do that, it will become like this. I will have 2 to the power of 3y, and then I will have dot, and then it will be 2 to the power, since I took it to the top, it will become a negative. That is the key thing there, but it will become -4y, and then it becomes 2 to the power -6 in this case. And then you continue. Now if you still remember the laws of exponents, which I said, if you are given a to the power m dot a to the power of n, bases are the same, you need to say a to the power of m plus n. You add the exponents. Similarly, here you can see that these bases are the same, so you're going to have 2 to the power of 3y plus -4y is equal to 2 to the power -6. So this is simple saying 3y minus 4y. If you know your algebra, 3y minus 4y is same as saying 2 to the power -1y, because it's 3 minus 4, which is equal to 2 to the power -6. So now to conclude this particular question, again there is a rule in exponential equations which says, if I'm given a to the power of m is equal to a to the power of n. Now if the bases are the same, therefore we can conclude that these exponents m and n are also equal, so you can say m is equal to n. Secondly, that is number 1, there is a second rule which says, if you are given a to the power of m is equal to b to the power of m. Now look again, if the exponents are the same, we can conclude therefore that a, the base, is equal to b, this other base. This is number 2, but in this case we're going to use the first one because it is the one that is applicable in this case. And the first one says, when the bases are the same, you can see here 2 and 2, we can also conclude and say the exponents are also equal. So 2 and 2, therefore we can say therefore minus 1y is equal to minus 6. Therefore divide by negative 1 on both sides, divide by negative 1 to get rid of that negative, and you can conclude that y is equal to, that cancels, is positive 6 in this case. So the answer there is y is equal to 6. And it was 2 marks, but I think it deserves more marks. Anyway, it was the wish of the examiner. Now we said our answer is y is equal to 6, so we can also test it. Very important for you to test. Remember here y is equal to 6, so where there is y, you put the value of 6, you put the value of 6, you check the left hand side and check with the right hand side. It must balance. So if I check with my left hand side, I have got fraction 8 to the exponent, my y, which is to the exponent 6, over 4 to the exponent 2. Now remember my y, so it's 2, you can put a bracket and put a 6 there, or you can say 2 times 6. If I put an equal sign, I'm getting 1 over 64 here. So on my right hand side, I'm getting 1 over 64 equal to, again I'm in my left hand side, I do my right hand side and say 64 to the exponent negative 1 equal to, again it's 1 over 64 here. So you can see that my left hand side is balancing with the right hand side, making that particular answer where it says y is equal to 6 is the one then that becomes correct in that case. As I said, we have come to the end of question number 3, and it was mainly focusing on the laws of logarithms as well as the laws of exponents and the equations in logs and the equation in exponents. So I'll encourage you to go through over this lesson again. And just to remind you, I've got a book called Mathematics N2 for the Underdogs, and this particular book covers extensively or intensively most of these laws that I was using here. And if you had gone through my book, you'll understand that everything that I'm doing here, that book actually comes with videos. You will see that there is a repetition of what I was doing, meaning if it was you in that particular exam, you would have not found these questions difficult because you would have actually done them in that particular study. So I will encourage that you grab hold of that textbook if you don't have it, because it offers a lot of information, and it doesn't come only as a textbook, but it comes with videos to make you understand. It's like you have a teacher without a teacher. So I'll encourage you to do that if you don't have it. Now we've come to the end of our lesson. I hope this was benefit to you. Thank you.